Okay, so this week I have section 4 of chapter 13, starting off with the topic of confidence intervals for mu based on t. So when the standard deviation for a population is unknown and must be estimated, t can replace z in order to find a confidence interval. You can use the equation t plus or minus t conf times s x. T conf is the number from the t table, and then sx is the estimated standard error of the mean. For finding t conf, to find an appropriate value, you would locate the cell entry intersected by the row for the correct number of degrees of freedom and the column for the confidence specifications. Specifications for confidence intervals are taken from the left-hand panel of Table B because the symmetrical limits of a confidence interval are analogous to a two-tailed hypothesis test. Both procedures require a specific number of standard errors to be added and subtracted relative to either the value of the null hypothesis or the value of the sample mean. Then we go into interpretation. The interpretation of t is the same as that of z. 95% of all confidence intervals will include the population mean. And then we have progress check for A. The answer is 14.7 plus or minus 2.26 times 0.26 equals 15.929 and 14.11 respectively. And for B, we can be 95% certain that the interval between 14.11 and 15.29 ounces includes the true population mean weight for all packages. In 13.9, we go over assumptions. So you would use a t rather than the z whenever, as almost always the case, the population standard deviation is unknown when testing hypotheses or creating confidence intervals for a population mean. When using t, it must be assumed that the underlying population is normally distributed, but even if this isn't the case, the t will retain most of its accuracy as long as the sample size isn't too small.